convert binary 1011 to its decimal equivalent. What does that equal, Bree? 11 is correct. I am supposed to convert the decimal 50 to its binary equivalent. So the other direction. What is that going to be? Yeah.
110010.
1 1 0 0 1 0. You sure? Positive. So if I do the math would be this is actually 1. This is our 2. This is our 4. This is our 8. This is our 16. This is our 32. You're telling me that if I have 132 and I add 16 to it and I add 2 more to it, it equals 50? You're saying 2 plus 16 plus 32 equals 50. So you're saying that 16 plus 32 plus 2 equals 50. So you're saying if I have 50 and I subtract 2 and subtract 16 and subtract 32, I have 0? Okay, you're correct. I was just checking to make sure we're on the same, we both knew the same answer. Okay, that is correct. All right, so yesterday we talked about binary or base 2. But there's technically infinitely more bases out there than base 10 and base 2. So that's what we're going to work on today, other bases. Not just binary, but other bases besides binary. So we start off with the Hindu Arabic system we use today uses powers of 10. This is why we call it base 10. How many symbols do we have in base 10? 0 through 9, which is 10. Do we actually have a symbol for 10?
No. It's a column.
We combine symbols, right? So I have only 10 symbols, and as soon as I get to 10, I have to repeat symbols. That's going to be a big reoccurrence with when we're talking about different bases. All right, so we call it base 10. However, positional systems can use powers of any number, not just 10. Yesterday we looked at binary numbers, which was based on powers of 2, or in other words, base 2. And we only had 2 symbols. We had 0 and 1. As soon as we got to 2, we had to start repeating stuff. Yesterday, I don't like this. I want to get aligned. Adios. So yesterday, 1, 2, 3, 4, 5, 6, 7. That's, the true dedicated math students. Leave, good luck though. But leave, good luck. But leave, have a good day. Good luck, good luck. Good luck. Okay. So yesterday we did expanded form. So let's think about 6, 7, 3. We could rewrite that as 6 times 10 squared plus 6 times 10 to the first plus 6 times 10 to the 0th. Do you remember that? So note that we change all of these. If I have 10 squared, 10 to the first, 10 to the 0th, I could continue on and go 10 cubed would be the next place value, 10 to the 4th would be the next place value, and so on and so forth. And that's because it's base 10. We should have a 7 and a 3 in there. Sometimes I just get trigger happy. And I zoom in too far on this. There we go. Well, that works for all bases. So base 10 started with 10 to the 0th for our first place value, 10 to the first for our second place value, 10 to the third, or 10 squared for our third place value, and so on and so forth. If I have base 2, before we were writing 1, 2, 4, 8, 16, 32. But another way we can write that is 1, 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. So this is another way to write all of those bases we were writing yesterday. And this way is a lot more efficient. Because these place values hold true if we're base 3. Base 3 is going to go 1, 3 to the first, 3 squared, 3 to cubed, 3 to the 4. Same thing with 4. And base 5, and base 6, and base 7, and base 8, and base 9, and base 10, base 11. Any base we're talking about, we can write the positions out like this. All right, where we have 1, 5 to the first, 5 squared. So that's going to be a huge deal that we need to know today. How to expand anything, not just base 10. But before we start expanding and converting stuff, we first have to handle some notation stuff. So when using bases denoting what base a number is, we use subscripts. We use subscripts, and that's what I did on our bell work. I told whoever's reading that this is base 2. Because 110010 could be base 10. It works. But this is base 2, so I write a little 2 there. I want you to underline really quick. If there is no subscript, it is assumed to be base 10. So if I don't write a subscript, it's base 10. Let's write some subscripts down. So if I have 2, 0, 4, maybe this is base 5. Another example might be 6, 3, 9. Let's say that's base 11. Let's do our favorite 1, 0, 1, 0, 1. And that's base 2. I'm going to do something here. Let's do 5, 4, 6. And I'm going to say that's base 4. That number right there is impossible. That number right there is impossible. Can someone tell me why it's impossible? Nicholas.
Because like 4, 5, and 6 aren't contiguous numbers.
4, 5, and 6 aren't in there?
Like, yeah.
Why aren't they in there, Mary?
Oh, I was gonna say it's not divisible by 4.
No, that's okay. Nicholas is on the right path. 5, 4, and 6 are not in there. What does Nicholas mean by that? Gracie. It's not because they're not perfect squares. Think about this. How many symbols do we have in base 10?
Oh,
Mary?
9.
Well, we have 0 through
Oh.
9. So we do have 10. We have 10. We have 0 through 9. But when I get to base, that's why I started off saying, when I get to 10, do I have a symbol for the number 10? Do I just have one? We have to reuse symbols, right? So how many symbols does base 4 have? Say it.
4.
It has 4. Can someone name all of the 4 symbols that we can use? Nicholas? 0, 1, 2, 3. What symbols am I not allowed to use? 4, 5, and 6. That's why this one is impossible. 5, 4, and 6 do not exist in base 4. Just like when we used binary yesterday, we couldn't use 2's. We just used 0's and 1's. If someone wrote 23 base 2, you'd be like, that's not. It's just 0 or 1's, dude. Come on. Get with it. All right? Won't be a huge deal here, but it's big. It's big to understand that how many symbols are allowed in each base system. All right, we're going to talk about converting. Converting another base to base 10. Now the trick to doing this is just writing it in expanded form. We're just going to write it in expanded form. So we're going to do that 1, 0, 0, 1, base 2. Now I know we could do this. We did it yesterday. But I'm going to do it in a different way. One that applies to any base. So what I'm going to do here is I'm going to say this place value right here. That place value right there is the place value 2 to the 0th power. Just like in base 10, it'd be the 10 to the 0th power. Let's see if I can go back to that. 10 to the 0th power is our ones place. So this is their ones place. This is base 2 ones place. Our next one's going to be 2 to the 1st place. Our next one's going to be 2 squared. And the final one's going to be 2 cubed. And I'm just going to write it in expanded form. I know we don't need to with binary, but when we get to more complicated ones, it's going to make your life a lot easier. So I'm going to rewrite this as I have 1 of the 2 cubes. Then we're adding on to it 0 of the 2 squareds plus 0 of the 2 to the 1sts. And finally, I have 1 times 2 to the 0th, or you could write 1 times 1. Now we're going to go ahead and add these. So I have 1 times 2 cubed. What's 2 cubed? 8 plus 0 plus 0 plus 1 is going to equal 9. I'm going to skip the next one because it's binary again. We actually know how to do binary pretty well because we practiced yesterday. We had homework on it. So I'm going to skip down to that bottom left one. So this answer should be 9 because I have 1 2 cubed. I have 0 2 squareds and 0 2 to the 1st and 1 of the 2 to the 0th. So I'm going to skip that one. I'm going to go down to the 4 7 2 6 base 8. And we're going to follow that exact same pattern, except now we're base 8. So that place value right there is going to be 8 to the 0th power. Our next place values actually are 8 to the 1st power. Then we have 8 squared. Then we have 8 cubed. And then we're going to write it in expanded form. So I have 4 times 8 cubed plus 7 times 8 squared plus 2 times 8 to the 1st. And finally, we're going to add 6 times 8 to the 0th power. All right, then simplifying this and adding stuff together, we're going to have this is going to equal 2,048 plus 7 times 8 squared is going to be 448 plus 16 plus 2, and our grand total is going to be 2,518. Are there any questions on any of those steps? Okay, I want you to do the next one on your own. I want you just to try that next one. I'm going to give you the answer. The answer you should get out is 3,507. So we should get out 3,507. See if you can do it. So we're going to go on to this next part. What about bases beyond 10? Now I'm a stickler for how many symbols we have. We have 10 symbols in our system. But if I want to do base 16 has 16 symbols. So that means if I'm ever dealing with base 16, we need an additional 6 symbols. Does that make sense? Okay, well, I got the first 10 covered. So if I'm doing base 16, I got 1 through 9 covered. We're done. We got 10 of them. I need 6 more. What symbols could I use to represent the rest of them? I have 6 more symbols I need to use. What could I use to represent them? We could use letters. We could use drawings. You could use colors. You could really use anything. Letters is the easiest way, right? And that's what we're going to use on this example. But remember, they're just symbols. Other cultures use completely other symbols as well. We're going to go ahead and use letters. So I'm going to say A, that's going to stand for my 10. B is going to stand for my 11. C is going to stand for my 12. D is going to stand for my 13. E is going to stand for my 14. F is going to equal 15. G is going to stand for 16. H is going to stand for 17. Can I stop at some point? How do I know when to stop? How do I know when to stop? Mary?
You get to your number,
When I get to what?
the base number.
So I should stop at 6. So I should stop at G?
I mean, the one more than wait.
Who knows when I can stop? Did I stop at the right time? Did I stop too late, too soon? Yeah.
F
I should stop at what?
now.
F? Why at F?
Because then you have 16 symbols.
Because then I have 16 symbols. I have 1 through 9, which is 10, 11, 12, 13, 14, 15, 16. The easy way to think about that, I think of base 10. I only have numbers up to 9. So whatever base I have, I want to go one number less. So if I'm base 5, my highest number is 4. If I'm binary, my highest one is 1, because it's 1 less than my base. So we're going to stop at F. And then we have 2 problems. We're supposed to convert the following to base 10. Well, it's exactly the same thing, except now we got letters. That first place value, since it's base 17, or 16, is going to be 16 to the 0th power. Our next base is going to be 16 to the 1st power. And then we're going to have 16 squared. Well, I have E 16 squareds. So I have E times 16 squared. So I don't want to write E's. E's aren't in base 10. So I'm just going to see what E actually equals. Well, E is actually 14. So that first one's going to be 14 times 16 squared. Plus our C. Well, C stands for 12. So our next one's going to be 12 times 16. And finally, we're going to have, well, 7's in base 10, so we just have 7 times 16 to the 0th. But 16 to the 0th is just 1, so you can feel free to write 1 or 16 to the 0th, your choice. Then when we add all of this up, I should come out with 3,783. Go ahead and do the next one. I will be doing it with you, so you can look up to see if you're doing it correct, but I'm not going to talk while doing it. Okay, so that's exactly what we're going to do. We're going to convert, we did those. We're going to convert base 10 to other bases. So when converting to other bases, we're going to go ahead and use division. We're going to talk about how it works. So the first thing we're going to do is we're going to convert 6 to base 5. All right, this is going to seem very cumbersome for just this simpler problem, but we're going to figure out how we're going to do this. And so we're going to do every step. So the first step I'm going to do is we're base 5. So with base 10, our decimal values were 10 to the 0th, 10 to the 1st, 10 squared, 10 to the 3rd. Well, with base 5, our different place values are going to be 5 to the 0th, 5 to the 1st, 5 squared, 5 to the 3rd, and we can keep going forever and ever and ever. Well, what I want to do is, I kind of started off pretty big. I'm going to rewrite that a little bit smaller. So like I said, I start with 5 to the 0th, I have 5 to the 1st, I have 5 squared, I have 5 cubed, and I go on and on and on and on. All right. The key thing here is to think about these as numbers. So I really have 1. I have 5 is actually here. I have 25 here. And here I have 125. And we could keep going from there. What I want to do is I want to pick from these numbers, 125, 25, 5, and I want to pick the biggest number that goes into 6 at least once. And that is going to be 5. 5 goes into it once. So we're actually going to do the division. So we're going to take that 6, we're going to bring it down, we're going to take that 5, and we're going to say 6 divided by 5 goes in once. And with division, I'm left with 1. Well, this 1 right here tells me I am going to use 1 of the 5 to the firsts. I should probably circle that in a different color. Yes?
If we put 5 into it twice, would it be 2 times 5?
Yep, it'd be 2 of them. So whatever number this is, and so I'm using 5 to the first, really, right? So I'm just seeing how many times it goes into it. Yep, but Grace is 100% right. If it went in twice, I'd put 2 times 5 to the first. I'd put 3 times 5 to the first. And then what we're going to do is we're going to say, well, only 1 goes into this guy here on the bottom. So I have 1 of the 5 to the 0ths. And then what we're going to do is we're going to write this in expanded form. So expanded form of this would be 1 times 5 to the first plus 1 times 5 to the 0th. Which is actually equal to 11 base 5. Because in effect, we're just working backwards. We're working backwards. So this is the expanded form of 11 base 5. I'm just condensing it to the normal 11 base 5. Does everyone get at least this step right here? All right, we'll refine this step up here, but we get this step, how I went from here to here. Okay. So we're going to step it up just a little bit. We're going to do 26 to base 2. Yeah, what's up?
Why is it 11?
Oh, okay. So it's pulled from, so this is the expanded form, right? I have 1 times 5 to the first plus 1 times 5 to the 0th. It's just like if, in the notes that we did yesterday, if I gave you 6 times 10 squared plus, 2 times 10 to the first plus 1 times 10 to the 0th. How could I rewrite that? 621. Well, 621 is this.
Yeah.
All right, these two things are the exact same. It's just much easier to write this. So if we go back to the one we have here, 11 base 5 is telling me I have one of these and one of these, so an expanded form would be this.
No. It's 5 plus 1.
No, but we're in base, so this is base 10, right? This is base 10. This 6, 2, 1 is actually telling me I have 6 10 squareds, I have 2 10 to the firsts, and I have 1 10 to the 0th, right? So if I did 11 base 5, that would be the same thing. I have 1 5 to the first, and I have 1 5 to the 0th power. All right, so we're not actually doing the multiplications. We're just actually pulling out the expanded form and making it condensed. Yeah.
Then 11 would be the base 5 number?
The 11 would be this right here?
Yeah.
Yep. As soon as you write base 5, it's base 5. So it tells you that this first number is how many 5 to the 0s we have. And this number is how many 5 to the firsts we have. We can't use our base 10 mentality on this. Because in base 10, I could just do 6 times this is 600, so I have 621. It's not really how it's set up. It's saying I have 6 of these, 2 of these, 1 of these. Same thing with the 5s. Yes, Mary?
So when Gracie said like if we went into it twice, would that make it 21?
If this went in twice, it'd be up 21 out of 2 of these, 1 of these. Does that make more sense? Okay. Let's just do the next one and see how that goes. And then we're going to do that bottom right one together, because that one's the most difficult, I think. All right, we're going to go to base 2. We're going to go to base 2. So as soon as I see it's base 2, I'm going to say, well, my different place values are 2 to the 0th, 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth, and we could keep going. I don't need to keep going. I'll show you. You'll learn when to stop. So 2 to the 0th is actually 1. 2 to the first is 2. 2 squared is 4. 2 cubed is going to be 8. 2 to the fourth is 16. 2 to the fifth is 32. Now I'm going to pick from that list. And I'm going to pick the biggest number that goes into 26 at least once. And what is that number? What's that biggest number that goes into 26 at least once? Mary? 16. So we're going to start with 16. 16 is our start. And we're going to go ahead and write our 26 down, and we're going to see how many times 16 actually goes into 26. Well, 16 goes into 26 once. So that tells me right there I'm going to have 1 of the 2 to the fourths. I'm going to go ahead and circle that because that's important. I have 1 of the 2 to the fourths. Do we agree with that? Okay. And then we just do our full division. I have 10 left over. Now what I'm going to do is I'm going to continue this pattern. I'm going to say, which of these numbers goes into 10 at least once? What's the biggest number that goes into 10 at least once? Gracie? 8. So we're going to drag this 10 all the way over here, and we're going to do another division. This time we're going to take our 8. And remember, our 8 is really 2 to the thirds. So however many times this goes into it is how many 2 to the thirds I'm going to use. Well, that just goes in once. And so we're using 1 2 to the third. And we have 2 we haven't used yet. Once again, I'm going to ask myself, are there numbers up that can go evenly into 2? And what's the biggest one that goes, not evenly, but which one goes into 2 at least once? Alec? 2. Yep. So we're going to do this one more time. We're going to say 2. We're going to divide 2. That's once. So that right there is going to tell me that I'm going to use 1 times 2 to the first. Did I use 2 squared? Did I use 2 to the 0th power? So how many of those do we actually have? I'm using 0 of them. So when I write this in my expanded form, we have to be careful. I'm using 1 of the 2 to the 4ths. I'm adding 1 times 2 cubed. Plus, how many 2 squareds am I using, Mary? You said it before? 0. So we're going to actually include that. We're going to say I'm using 0 of the 2 squareds. I'm using 1 of the 2 to the firsts. And I'm using 0 of the 2 to the 0s, or 1s. So that's the expanded form. To put it in our normal form, we're just going to take those first numbers and write them down. So it's going to be 1, 1, 0, 1, 0. And we're going to put base 2. I'm going to skip to that bottom right one. The bottom right one's a little more, and then I'll let you do the other one by yourself if you already started it. So I'm going to go to the bottom right one. So we're going to convert 299 to a base 8 numeral. So since we're base 8, we're going to list all of the bases with 8. And that would be 8 to the 0th power, 8 to the first, 8 squared, 8 cubed, and I'm actually going to stop at 8 cubed. Because if we look at these values, 8 to the 0th power is 1, 8 to the first is 8, 8 squared is 64, and 8 cubed is going to be 512. Are we ever going to need 512? Are we ever going to need 512? I know it's a small class. No, we're not even going to need that one. That was extra. I don't even need that guy, because 64 is the biggest one that goes into 299 at least once. So that's our starting point. Our starting point is this 6d4. And we're going to put that 299, and we're going to ask ourselves, how many times does 64 go into 299? And that's going to be 4 times. And since it goes into 4 times, that means I have 4 groups of that 8 squared. So Gracie, to kind of answer your question it took here, if it's 4, you put 4 of however many groups you pulled it off. Does that make, are we good here? Does this make sense? Our starting off one? Okay. So we continue down, and in our calculator we would just do 4 times 64, and we would do the full division. So I'd have 256. 299 minus 256, we're going to be left with 43. I'm going to move 43 over here. And now I'm going to say, well, I only have 8 and 1 to choose from. It must be 8. 8 must be my next one, because 8 goes into it at least once, and it's bigger than 1. So 8 is going to be my next guy. And 8 goes into 43, I'm pretty sure 5 times. Well, that tells me that I have 5 groups of the 8 to the firsts. Circle that because that's important. 5 times 8 is 40. I'm left with 3. You could either see how many times 1 goes into 3, or you can just say I'm left with 3. So that must mean I have 3 groups of 8 to the 0ths. Now we just write this in expanded form. And we have 4 times 8 squared plus 5 times 8 to the first plus 3 times 8 to the 0th power. Well, we just take our first digits because this is expanded form. And I just rewrite it as 4, 5, 3, base 8. Do any of those steps not make sense? I know this is much more difficult going this direction than the other direction, right? Because the other direction was write and expanding and then add it. Gracie.
Oh, I don't.
Yeah, I figured when you try to retract the hand rate. All right, what I want you to do really quick, I want to make sure that you know how to do this. I want you to do 355 base 7. I'm going to come around and check your answers.